Today I'm going to talk about SSL. I have a pretty long presentation, as in I have far too many slides. So there's about 47 different slides. So what I'm going to do, because we only have 45 minutes, I'm going to cherry pick. So I'm going to focus on a couple of, probably was the most important, the results of the survey. And you can then use the slides later and read them and look into the details. There's a lot of details included in the slides. So this is the agenda for today. Briefly, we're going to ask ourselves, well, or not, why do we care about SSL? And then look at how we assessed all the servers on the internet, and then look at the SSL survey findings, and then look toward the future. This part is easy. The first question is, why do we care about SSL? And this part is really easy. We care about it because it's the security backbone of the internet. And when I looked at it, I was really surprised that there was actually very little attention given to SSL. It was surprisingly difficult to configure. There was no documentation, no tools to help people configure it properly. And no one actually knew how SSL is used on the internet, and that's pretty much how SSL Labs was born. So SSL Labs is basically a website that runs a bunch of projects that are very useful for SSL, and long term we would like to make it more into a community effort where people who are interested in SSL can actually collaborate. I will go briefly to the project. We have the SSL fail model, which will enumerate all the possible things in which SSL and certificates can fail. Then we also have the rating guide, which can tell you how to assess the configuration of a particular SSL server. But by far, the most interesting part of the SSL Labs website is the assessment engine. The assessment engine is the free online tool that's available to everyone, where you just go to the website, type in the domain name of the server, of your SSL server, and the website will go there. It will perform a bunch of tests and come back to you with detailed results. And on this slide here, you can actually see what the results look like. There's quite a lot of stuff going on there. In every test, we send about 2,000 packets and maybe from 200 to 300 connections, trying to get to the bottom and assess every single aspect of a site's configuration. But what's the most important is the configuration. The quality of the configuration is actually summed up and presented in a very user-friendly way. So even those who are not really SSL experts can look at it and say and figure out if it's good or not. And the other really nice aspect of it is that those who are SSL experts or interested in SSL can actually look at the detailed information and find out exactly what is wrong. So the test is pretty comprehensive. It will even look at the domain name. It will find all the servers that are behind the domain name, and it will assess every single of those servers. And it will often it will also point to inconsistencies in the configuration among the servers behind the domain name. So that's just a very brief overview of the assessment engine. And again, the benefit of the tool is that you can use it yourselves. You can, and there's a whole idea of SSL Labs. You can just take this website, analyze the configuration of your SSL server, find the flaws, if any, and just fix them. That's the whole thing. Now, the interesting thing is the survey. Once we had the assessment engine, we said, okay, let's look at the internet and let's try to see how SSL is used on the internet. And to do that, we have to find the SSL servers first. So the finding part is actually a survey within a survey, and this is where we look at domain names, we look at virtual web hosting, and we look at ports 80 and 443. And in trying to find as many SSL services we can, we will also find out, well, how many sites are actually running SSL and how many sites only run just non-HTTP on port 80. There are many approaches in which you can look for SSL servers. You can scan the entire IPv4 space, for example. You can crawl the internet. You can look at the domain name registrations. We decided to start with the domain name registration. So what we did, we looked as to how many registered domain names there are, and we discovered there's about 200 million of those. And then we went and got hold of all those, well, most of those domain names. So it was relatively easy to get hold of 57%, or about 120 different domain names. And then we started with that data set and started to look into all these domain names and how they're configured. We just wrote a very special lightweight analysis tool, which will send as few packets as possible and basically just ping each of the domain names in each of the IP addresses to see whether it will respond at ports 80 and port 443. It will even fetch the certificate in the process, but it will not perform any SSL handshake. It will not do any of the time-consuming stuff. And with that sort of lightweight approach, we were able to perform, use a single server, a modest server running 2,000 tests in parallel, and arriving to about 1,000 probes per second, which was really fast, and in any case, fast enough. And here's what we found. The next couple of slides is really just me drilling into the results of the first scan. Starting with 120 million domain names, the first thing we discovered is about 1/4 of those doesn't even run. So either it's not in DNS at all, or there's no response to either ports 80 or port 443. So these are some parked domain names that nobody really uses. And then we looked into ports 80 and port 443, and what you can see here is that most sites actually run HTTP. So it's 99.35%, but that's slightly over a third will run something on port 443. And then we looked only into the port 443 and found SSL only about 2/3 of all the sites. And the other third was sites running protocols other than SSL on that port. We found quite a few secure shell servers, MySQL servers, other protocols, and we have also found quite a lot of plain text HTTP also running for port 443. In the end, about 1/6 of the domain names that we have scanned runs SSL, and that's a very interesting number. But even those, then we looked even deeper. We looked into the certificates and looked into the names that are written embedded in these certificates, and then we have discovered it's only a very small number of domain names actually have certificates whose names will match the domain names. It's about 720,000 of these, and it's only 3.17%. So this is a very optimistic assessment where we could say that 3.17% of the internet runs SSL. I'm sorry about that. So what we have there is, that's the one data set that we started with. The other data set is, we took Alexa's top 1 million domain names and we looked at that data set. And you can see there, there's the pie, the donut on the right. The match, the certificate match will be in a higher percentage, almost 1/4 of Alexa's top 1 million sites will actually have certificate names that would match domain names. So you can see that where it matters, and the assumption is that in the top million, Alexa's top million sites, you have popular websites. Where it matters, people take care of SSL more and configure it better. So what does this tell you? Well, basically, we looked at the 100 domain names, and if you look closely, what we have discovered is that behind the 120 million domain names, there's only 5 million IP addresses, which means that virtual web hosting, and we knew this, is very popular. And there's on average, a single IP address will host about 20 or 20 or so IP addresses, and we looked at the SSL sites. It's about 1 in 10. And there's one obvious problem, which is a big problem for SSL that we can see from these numbers here, is that there's no way at the moment that you can tell whether a site runs SSL or not. If you have a domain name, the best thing you can do, you can type it in the browser and see what happens. In many cases, as we can see from the 22 million invalid certificates, you will get some sort of a problem. And the only way to really figure out if a site has SSL is to look at the website and see if it makes sense, if it correlates with the domain name. Now, the technology to do this is there. We have DNS server records, which could be used to determine whether a site wants to use SSL, but it's not currently deployed in browsers. So that's one thing that we should be looking in the future. Anyway, the whole point of this first study is to arrive at a pool, at a data set of certificates that we could reasonably, that we would say were intended. And that's why we looked at, insisted that there's a match between the names and the domain names. And using the 720,000 certificates from the domain name data set, combining with the Alexa data set, and mining the domain names out of the certificates, all the certificates we saw, we arrived at a data set of about almost 900,000 certificates, and then we decided to take those and look into each of these servers in depth by running complete SSL assessments over those. And it is our estimate that these 900,000 certificates, they're about from 25 to 50% of the entire commercial SSL space. One thing to remember is that the data set is biased. The 120 million domain names we started with are all .com, .net, .org, biz, info domain names, but none of the country-specific TLDs. So as you can see here, by extracting the organization, the location of each organization from each of the certificates, you can tell that by far by far is, for most of these we don't know, but then is the US we have, and then far down there is Japan, Great Britain, Germany, and so on and so forth. So that's the first part. And now, now we have the more interesting part, which is the SSL survey of the 900,000 certificates. For this survey, we used 3 servers, 2 of those which were that were running SSL assessments. It's about 400 assessments in parallel, and the speed of about 5 assessments per second in total. And median duration of a test was about 65 seconds. So we don't need a lot of CPU. The greatest factor that influences the speed of an assessment is network latency. Because we have so many packets, the further away the server is from us, the longer the test it took. So the conclusion is that all the tests were taken, took 2 or 3 days each. So CPU resources and the hardware, that's not a problem. By far the most consuming aspect is time. Performing these tests, writing the tools, analyzing them, and making sure that the numbers are valid. So from now on, I will focus on what was discovered. And here's a very interesting slide. We looked at the 900,000 certificates and tried to figure out how many of those we can trust, which is about 72%, slightly over two-thirds. And then we looked, which is sort of encouraging, and that we looked into why we couldn't trust all the other ones. And by far the most common reason is that simply they have expired at some point in the future. Then we have a bunch of self-signed certificates, and then followed by about 40,000 certificates that were issued by the certificate authorities that were unknown to us. And then we have a couple of other reasons, but they're not really common. You have to remember that our methodology excluded any mismatch between the host name and the certificate name, because we really wanted to find those SSL servers that are operational. And this is the closest that we can get to.